Welcome to my channel. Today, we examine the intriguing concepts of causation, its integral components and principles. Causation is the relationship between cause and effect, illustrating how one event triggers another. It's the backbone of understanding why things happen. Now, let's explore the characteristics of causal factors, as well as how to determine cause and effect relationships using relative risks, odds ratio, and the Bradford-Hill criteria of causation. Causal factors are the specific conditions or variables that contribute to the occurrence of an event. Identifying them helps unravel the complex web of connections shaping outcomes. For example, in health, smoking, causal factor, may lead to lung cancer, effect. Understanding causation and its factors is essential in fields ranging from science to social sciences, guiding research, problem-solving, and decision-making. So, whether it's unraveling mysteries or improving outcomes, recognizing causation and causal factors empowers us to navigate the intricate tapestry of cause and effect. Causal factors are classified based on their nature and relationships. Let's look at what these are. Direct and indirect causes. Direct causes are immediate factors directly linked to an outcome, while indirect causes contribute to the context of these direct factors. In healthcare, consider infectious diseases. A direct cause could be a specific pathogen, such as a virus causing the flu. Indirect causes may involve poor sanitation or compromised immune systems, creating an environment conducive to the pathogen's spread. Quantifying this, a study could assess the relative risk of contracting the flu in individuals with compromised immune systems compared to those with robust immune systems. Proximate and ultimate causes. Proximate causes are immediate and observable factors, like excessive calorie intake leading to obesity. Ultimate causes provide a broader understanding, such as societal factors influencing food choices. For instance, a study might examine the odds ratio of developing obesity in communities with limited access to healthy food options compared to those with ample choices. Necessary and sufficient causes. Necessary causes must occur for an outcome, but may not be sufficient on their own. In disease causation, necessary factors must be present for the disease to occur. For example, tuberculosis or AIDS requires the specific pathogen and a compromised immune system. In rare cases, a factor alone can be both necessary and sufficient, as seen with Vibrio cholerae causing severe diarrhea without additional factors. Necessary but not sufficient factors, like those in carcinogenesis or thrombosis causing cerebrovascular disease, involve multiple steps or factors in specific sequences. Sufficient but not necessary factors, such as exposure to benzene causing leukemia or atherosclerosis leading to myocardial infarction, can independently cause a disease, but alternative factors may also contribute. Some factors, neither sufficient nor necessary, are typical in chronic disease relationships where multiple interactions influence disease development. Internal and external causes. Internal causes originate within the system being studied, while external causes come from outside influences. In healthcare, internal causes of stress may include personal factors, while external causes could be work-related pressures. Example: a study might explore the odds ratio of developing stress-related conditions in individuals facing high work-related pressures compared to those in less stressful environments. Now, let's examine the concept of single and multiple causes. Single causes imply that one factor alone leads to a certain outcome. For example, in certain infectious diseases, such as with the human immunodeficiency virus, HIV, exposure to the specific pathogen can lead to illness, HIV infection. On the other hand, multiple causes involve a combination of factors leading to an outcome. It's more like a web of interconnected factors, each contributing to the final result. Consider cardiovascular disease, a condition often resulting from multiple causes. Factors such as high blood pressure, diet, obesity, and genetic predisposition can all contribute to the development of this disease. Likewise, HIV alone cannot cause AIDS. Multiple factors such as high viral load, low CD4 cell count, poor diet, or the presence of AIDS-defining illnesses are needed for a positive AIDS diagnosis. So how do we determine causation amidst this complexity? To understand the relationships among phenomena, we utilize several tools. Relative risks and odds ratios, for instance, help us quantify the strength and direction of relationships between factors and outcomes. A high relative risk or odds ratio between a factor and a disease suggests a strong causal relationship. For instance, in a study examining the association between smoking and lung cancer, lung cancer occurred in 10% of the participants who smoke, while 3% of participants who do not smoke experienced the outcome of interest. The relative risk would be risk of lung cancer in smokers divided by the risk of lung cancer in non-smokers, which is approximately 3.33. If the relative risk is 3.33, it implies smokers are 3.33 times more likely to develop lung cancer than non-smokers. Meanwhile, an odds ratio of 3.6 indicates that the odds of developing lung cancer for smokers are over 3 times higher when compared to the odds for non-smokers. These metrics provide a numerical grasp on the strength of the association. The higher the relative risk or odds ratio, the more likely it is to make a causal inference. Likewise, a positive result indicates there is an association, while negative results indicate no relationship between the variables of interest. However, interpretation should consider contributing factors. If the study on lung cancer accounts for genetic predisposition, environmental pollution, or radiation exposure, the adjusted relative risk and odds ratio would offer a more nuanced understanding, isolating the impact of smoking on the outcome lung cancer. For instance, an adjusted relative risk of 2 might suggest that, even when genetic factors are considered, smokers still have twice the risk of developing lung cancer. These numbers assist in clarifying the role of the causal factor, smoking, amid other influences, contributing to a more robust assessment of causation. The Bradford-Hill criteria of causation, on the other hand, provide a more holistic approach to determining causation. These criteria consider aspects like consistency, specificity, temporality, and more, to evaluate whether a relationship is causal or coincidental. Named after Sir Austin Bradford Hill, who proposed them, these criteria have been a cornerstone in the field of epidemiology. The Bradford-Hill criteria consist of 9 elements, each providing a different perspective on the causal relationship. 1. The strength of association. This is usually measured through relative risk or odds ratio that we discussed earlier. A classic example of a strong association is the link between chimney sweeps and scrotal cancer in 18th century Britain. Next, consistency with other studies. Consistency refers to the repeated observation of an association in different populations, circumstances, and times. For instance, multiple studies have linked excessive sugar consumption with type 2 diabetes, demonstrating a consistent relationship. Now, specificity of association. This criterion suggests that a disease has only one cause. For example, in the context of HIV causing AIDS, the specific relationship between HIV viral load and its depletion of CD4 cells illustrates the high specificity of HIV for causing AIDS. However, it's worth noting that the complex interplay between various exposures and a specific outcome makes this criteria weak one. Another element is temporal relationship. Temporality requires the exposure to precede the onset of the disease. Cohort studies on smoking and lung cancer have demonstrated this sequence of events. Next we have dose-response relationship. This refers to an increasing risk with higher levels of exposure. The relationship between the number of cigarettes smoked and the risk of lung cancer is a classic example. Another criteria, biological plausibility. This requires a plausible biological mechanism between exposure and outcome. For example, the link between oxygen levels and retinopathy of prematurity, a condition that affects premature babies, is biologically plausible. Also, consistency with other available evidence. This requires the association to align with the current knowledge of the natural history and biology of the disease. And 8. Experimentation. Experimental evidence can provide strong support for a causal relationship. Finally, 9. Analogy. Sometimes the effect of similar factors may be considered. Remember, while each of these criteria aids in the assessment of causality, not all of them need to be met for a causal relationship to be established. A comprehensive evaluation considering multiple factors is often essential to draw robust conclusions in epidemiology. As we navigate through the concepts of causation, this is immersion concepts learning made simple, practical, and impactful. Your support matters, so do remember to like, subscribe, and share this video to help spread knowledge. Until our next exploration, take care and thank you for being a part of this learning journey.